Hello, everyone. Welcome to this edition of the DSSC Insight Series, the monthly webinar appointment by the Data Spaces Support Center. This month, we're very happy to bring you a very interesting topic from our community of stakeholders with this webinar titled Building Synergies, Lessons from Manufacturing and Green Deal Data Spaces. We will do so with the following lineup. So we will have an introduction from Gianfranco Cecconi from Data Spaces Support Center. Then we will have unveiling of key milestone from the smartness data spaces by Carmen Polcaro from Innovalia. We will have then an introduction on the Sage Green Deal data space by Mark Dietrich from the EGI Foundation. We will then we will go a little bit deeper into two use cases of the Sage data spaces: the net zero manufacturing use case with Joel Sepulveda from Innovalia, and then the circular textile use case by Anne Ronell from Reverse Resources. And then we will have a Q&A. As a reminder, you will be able to ask questions in the chat throughout the webinar. We will do our best to answer them all. And any unanswered question will be left to the end. So stick around for the Q&A session at the very end. Just a couple of housekeeping items. So this webinar is recorded, and you will be able to watch the recording of the webinar on the YouTube channel. To access your YouTube channel, you can scan the QR code in this slide. On our YouTube channel, you will also be able to see all the previous Insight series, educational videos, and most of all, the recording from our annual event in Darmstadt and in Warsaw, which just took place this spring. Last but not least, to stay up to date with everything that we do, do not hesitate to subscribe to our newsletter. You have the QR code in the slide. And also you can click on the link in the slide, and which will be posted in the chat. Now, without further ado, I am very happy to start the webinar and to give the floor to Gianfranco.
Thank you, Anna, and good afternoon, everyone, and welcome to today's Insight Series webinar. Whenever I host a webinar like this, I usually introduce myself as the Project Executive Director, working alongside our Project Coordinator, Professor Boris Otto. But I am not going to do that today. Today, I am one of you in the audience. I'm a user. More specifically, today, I'm a data scientist, and I'm here looking for stories, tangible experiences that help me understand whether all of this talk about data sharing and data spaces is actually real. I've always felt that if you truly want to change the world, we're not going to get very far just with shiny textbooks, dazzling technology, or piles of money. What we really need are stories, the stories of what we've actually achieved with data. Those stories are the ones that stick in people's minds, right? Stories that change the culture, stories that create a moral imperative to share data. And Uncle Gianfranco here will offer my own story. So 11 years ago, I was working as a data scientist for real at the Open Data Institute, the ODI in London. The mayor of the city had decided to shut down 10 out of the 110 fire stations serving the city. Some very expensive consultants had advised the mayor on which stations were least necessary, and the prospect of saving taxpayers' money was, of course, very, very welcome, right? Naturally, the firefighters were not too happy. To them, the decision seemed to be based solely on budget cuts, and they had good reason to question how those choices were made. The Londoners living near those stations weren't happy either. Of all places, you're shutting my fire station, you're putting my family and my home at risk. Reasonable, right? And the consultant and the mayor had not published their data or models. To make matters worse, the mayor had a clear political leaning, and the areas affected by the closures happened to be strongholds of the opposition. So people started even wondering, are we being punished for how we voted? So at the ODI, when I was at the time, we weren't interested in party politics. We were just concerned about the unnecessary lack of transparency. So we asked ourselves, could we validate the mayor's decision only using publicly available data and the skills we had in-house? And we started working. It was a statistician, a web developer, and myself. The Fire Brigade of London was already publishing incident logs, including how long it takes for a fire pump, the kind of truck that you use to run and take fires off, to arrive at the scene. The Ordnance Survey, that is the England and Wales cadastral agency, had excellent data describing the topology of the streets of London. OpenStreetMap we use for the maps that we could display on the website. And the Office for National Statistics of the UK had released the latest census results, so we could use that to estimate the local population levels. All of it at the time was already published under open licenses, thanks to the UK early leadership in open data. This was before the term was even mainstream. At the time in Europe, we were simply talking about public sector information. I'm sure many of you will remember. There was a problem though. Open data was not enough. We realized very soon in the process that London is a massive commuter city, of course. Fires don't always affect residents. They affect workers, tourists, people passing through. So while open data could get us a long way, it wasn't enough. To understand the impact of a fire station closure, we needed to know how many people were put in danger, or more in danger, and then the fire station was still there. So what we did was negotiating with a big mobile operator to share a couple of days worth of what is called usually footfall data, that is anonymized aggregated counts of how many mobile phones are active in a different area of London at different time. This is commercial data, borderline sensitive sometimes, but we gave them enough assurance that they could trust us in using this. We just needed estimates of how many people were on an average weekday or weekend. So that is where the project shifted from an open data exercise to an actual data sharing exercise with the kind of resources we had there. A few weeks later, we had a working statistical model that we were confident in. We had a public website where anybody could simulate what would happen if one fire station is close to another one. You could choose the 10 station the mayor selected, or you could pick other fire station. You could use the census data, or you could use the footfall estimates. And that's the twist. The model we created supported the mayor's decision. So if you really had to close 10 stations, those were actually the 10 you would choose. The expected average attendance time to a fire only went up by a few seconds. And that's not where the story ends. We published all of our code under an open license. We encouraged others to modify the mathematical model, the statistical model we used. And probably the proudest moment was when we could attend an event organized by the firefighters to discuss the topic, and they actually thanked us to produce that kind of insight that they could use to understand what was happening. So Carmen, Mark, Joel, Anne, no pressure, because this is the sort of story I would like to get from you. Yeah, so relax, it's fine. I'm sure you have enough stories to tell. But to the others watching, I hope you find your own stories, because you will also need that kind of energy that I had 11 years ago to go on for another 11 years and possibly beyond. So with this wish, I would hand over to Carmen. I believe she's starting today. Am I correct, Anna?
Yes, you are. Thank you very much, Gianfranco, for the wishes and the and your story. Carmen, I think the floor is yours. If you want, you can share.
Thank you very much, first, Anna, for inviting me to this Data Space Support Center Insight. And thanks, Gianfranco, for the very useful introduction. The story you are telling of how sensitive data that we would like, the first idea would be to keep it private, can be very useful to enable more valuable services. So let me share my screen. So in Smart Tenants, we are building these stories, but in the manufacturing sector. First, let me introduce you. I'm Carmen Polcaro, project manager project manager from Innovalia, a research and technological center located in the north of Spain. And I'm here as the coordinator of the Smart Tenants project. You will see in the next slides that the Smart Tenants Consortium is a very big one. So the first question arises is that why so many different entities are committed to this project. The main reason is that we all share we are all aware that data sharing, it is the foundation of the future economic spaces, especially now with the advent of the industrial artificial intelligence. Moreover, inside the EU data strategy, there is the intention from the European Commission to develop common data spaces in 14 different sectors. And we are in charge of developing the manufacturing data space with the project Smart Tenants. As you can see, we have 42 partners, 3 associated partners, a budget of 14 million with a contribution from the EC of 8 million. And if you take a fast look at the logo, you will see very different kind of entities. We have academies, we have a big technological institute like the Fraunhofer, and we have big companies, especially in the equipment sector. You can see Prima Industria, for example, and many more. We will see a bit more details of what they are providing to the project. So regarding industrial AI and specifically in manufacturing, these are very recent data on the challenges that AI in manufacturing is addressing. And there is no surprise in seeing as one of them predictive maintenance, because it is crucial for equipment manufacturer and their customer to ensure a high level of predictive maintenance and asset management. There are the focus of Smart Tenants. So what we would like to boost with Smart Tenants is a data-driven transformation. We know that 8% of industrial data is never used. This happens because data is considered inside the industry, and rightfully considered, as an important asset, something valuable, confidential, that have to be used with certain attention and caution. So even if manufacturing has not adopted completely the data space solution, there is data transaction and data sharing between companies of the manufacturing sector. But they usually follow the paradigm, the one data, one use, or one partner, one project. This means that a data set is shared between with a specific partner and to do a specific action. So we would like to propose and put in practice with the data space Smart Tenants a different paradigm. We are based on for a data space, the data space that we consider is based on the definition given and updated by the Data Space Support Center. Specifically, if we take a look at the V2.0 of the definition of the data space, there are certain aspects that we have highlighted. In particular, we are talking about we need interoperability, we need common governance principles, standards, and practice. We need to be able to enable services on top of these spaces and to guarantee trusted data transaction based on trust between participants. Where are at the moment with the development of a data space? We are in this phase that is called Valley of Death, according to the venture capitalists, or the truth of disillusionment, according to the Gartner hype cycle vocabulary. But more or less, it's well, the concept is the same. And despite the appearances, it is not a bad place. We are in this position where, from this technology advancement, we are almost ready to transform these technologies in a commercial solution. We are not in bad place because here this disillusionment comes from having clearly identified the challenges, the big challenges that are ahead of us. But also we are starting to see how we can address them. So the smart tenants mission is to support the effective organization of data and industrial ecosystem to address specific manufacturing challenges. What we mean is that companies are committed to create this manufacturing data space because it is important for them. They have specific challenges they can address only with a large data sharing. And in particularly to address challenges related to the manufacturing supply chain. What we would like to achieve in smart tenants is to guarantee the asset 4.0 capabilities. It means the capability around the equipments that are sustainability, modularity, flexibility, and resilience, interoperability, but also without ignoring the factory challenges. So what we are what we need to integrate is this horizontal, keeping into account the ecosystem of the equipment builder and the vertical challenges that are around the asset, this same equipment, once they are operating in their reference sector. This is because each machine builder that are part of the Smart Tenants project has their own ecosystem made of their supplier, their clients, of the different companies of the same group that are contributing to the building of the equipment. But they also need to be in a larger ecosystem once this machine operate in their final sector. That we will see, we have several sectors that we deal in smart tenants. So the mission is to facilitate a neutral cross-sectorial data space where data can be provided along the complete asset life cycle from the different stakeholders that interact with this asset. So we are talking of 360 data integration. And also this is the main difference, or maybe the main added value that the smart tenants build on top of other initiatives already mature, like Catena X and SSC SN, that they have data sharing, data integration in an horizontal way along a specific sector. So what we need to do here is not only, well, we have to work on two different levels. On one side, we have to enable the companies, the machine builder mainly that, machine builder, but not only, but the machine builder mainly that are in the project to create a data space within their ecosystem. And at the same time, having enabled the data space federation, the connection between the different data space across the value chain. And this means also to involve different kind of entities. So we have a digital platform, edge infrastructure, sensor and data, cloud infrastructures, and the factories. This explains once again why we need a very big consortium. In this picture, you will see how we our idea, what we are developing in smart finance to address these challenges and to make real this mission. If you see below, you will see well where the data actually are. So the data sets are on data platforms that are owned by the companies, the machine builders. And this through the needed connector will be connected with a layer for that is sectorial. So we will have intermediary in the different sectors that we are covered by the project. On top of that, we will have our smart finance federated data platform that will enable this cross-sectorial data sharing, and then the portal that will be the interface that will enable all the stakeholders to accede to these services. So beside the federation, as you can see, there are other objectives that we have to reach, create a data space ecosystem around the concept that we have seen, enable a data chain trust framework, because we are all aware the trust is the main aspects that we need to guarantee to make this real. The infrastructure for the portal, and then also enable operative collaborative operation and services on top of this data that are shared. This is our idea, our vision. So how we think we can go from the paradigm of one data, one partner to many data for many uses and many projects. We have several pilots, of course, inside the project, which have these pilots are the ecosystem around the machine builder that we are developing. The idea here is first, well, the objective is to demonstrate the business values of the data space data space in manufacturing in real use case, and then to create smart kits, keep it together for the replication after the project. So, talking about the pilot, I guess I have a couple of minutes more. So they cover this for a business application. But I would like, and these are the different industry. We have machine tool, battery, automotive, textile, and the process industry. They are located in several countries in Europe, and also supported by technological provider from several countries. Well, I would like to use these minutes that's very fast to see 2 or 3 an idea of the pilots that we have. Here we are okay, here we have a pilot located in Spain, where a connected data space will enable the integration of digital twins and the secure data exchange, enabling a proactive maintenance. This is in the sector of metrology. It means machines that are used in the industry for quality control. And here the business value is in optimize performance, ensure secure data transaction, and to enable automatic data gathering to reduce errors. Another example is from Prima Industrie, machine tool fleet management with data space, where the focus is to implement predictive maintenance functionalities for 2D laser cutting machine supported by artificial intelligence algorithms. Here, the business value is mainly in the reduction of spare part inventories, increase the average life of the system, reduce average intervention time. Finally, just a fast view on the sector for textile and clothing, where Piacenza, one of the textile production leader in Italy, will use the data space for something a bit different, which is the implementation of the digital product passport on their product. The business values are mainly in cost and time reduction to improve the environmental performance management, and also to ease the regulation compliance for SMEs. So, as I was saying at the beginning, we don't have complete stories as the one told by Gianfranco earlier, but we are on a good track to have them very fast. Thank you.
Thank you very much, Carmen. We already have a couple of questions in the chat, so please keep them coming. And then, of course, again, please stick around until the very end. In the Q&A, we'll be able to know more about all the topics. So now we move to the Sage data space, and then we have a short introduction by Mark from the EGI Foundation. Mark, the floor is yours. And enjoy.
Okay, hello. This is always the most nerve-wracking part, where you have to turn on the button that makes the audio work and you have to make the sharing work. So I'm now going to do the next magic trick, which is to go to the presentation mode. Are you guys seeing the right version of this slide? Thank you, Anne. So I'll give you a quick project overview of SAGE, which is the data space for a sustainable green Europe. This is the Green Deal data space that the Digital Europe program is funding in connection with the European Strategy for Data, which, just as an interesting point, is now 5 years old. So here we are at the implementation point. So SAGE is a 36-month project with over 40 partners, 16 million of funding that started a few months ago. The IDC, International Data Corporation, is the lead, and I am the technical coordinator, wearing actually my Bloodstone hat. We have 10 use cases in the project. which I'm showing here, and we're going to get here in detail from two of those. So I'm not going to spend time on this now, but they will give you, Anne and Joel will give you the story that Gianfranco is looking for. So, or at least I hope so. So that's the plan. So let's talk a little bit about how SAGE is going to be organized. It's hopefully going to be organized in a simpler way than we've historically had to think about it as we look at the technology from Gaia X, from IDSA, from BioWare, from lots of people. We are looking at a more homogenized architecture, and I wanted to share it with you so you understand how the pieces work. The SAGE data space is the control plane. It's the place where decisions are made about how data is shared and what processing can be done with the data at the under the direction and with the authorization of the data holder, the data rights holder, or the data provider. So that's a key point. It's always been the key point of data spaces, is to preserve that control. So what does that look like? Well, we have, and there's now consensus about the idea that there are different ecosystems that can be supported within a single data space. And we need an ecosystem governance framework that is sitting, if you will, in a governance plane where we'll have some documents. Some of them might be agreements. Some of them might be machine readable documents that talk about policies and trust anchors and fun things like credentials, verified presentation, techno stuff that we're working on in the SAGE data space to make as simple as possible. All of those rules and regulations and basically choices that are made by the data holders are managed and implemented by the data space through a little piece of software called a policy information point. And that will decide whether somebody has the right stuff, the right credentials to access something. And then that'll be passed on to the connectors that many of you have heard about, which is the policy execution point. And that's the gatekeeper that basically hands off or tells the data plane. And this is the stuff that the data space doesn't own. The people who are participating, the companies, the data providers, the use case sponsors, et cetera, the actual participants as companies and so on. It's their storage, it's their processing, it's their computers that have the data and that will just, actually implement these policies. So that's what we're showing here. Within SAGE, we will have various mandatory services like identity management systems, monitoring systems, help desk, secure processing environments, et cetera, as well as optional SAGE services that can be used. So for example, the vocabulary servers, registries of metadata, and so forth. We're in the process of building up that catalog of capabilities with our partners. We have a number of technical partners in SAGE, and they're bringing that together. So the key point is there's interoperability between ecosystems because we're using the same words and sentences for the governance frameworks, and we're also using the same technology, ideally, so that we can have interoperability between data spaces. So going on a little bit just to explore this, you might have a situation where somebody in use case one, a participant in use case one says, gee, I like the data that's over there in use case N or 2. And so how do we do that? Well, the diagram here shows you how the control plane, the control protocol handles that, and then eventually the data is moved. And the same thing might happen between two data spaces. We're not changing the components. We're just drawing longer lines and connecting across wider distances, if you will. But the governance frameworks are still interoperable, and the technology in the data spaces is still interoperable. So what are our priorities as a project? Well, of course, we want to bring the 10 use cases into production. That's very key, and we'll hear from 2 of them in a moment, so I'm not going to steal their thunder. In addition, we want to expand the kind of data that's available, not only for the data that is required for the uses and by the use cases, but also additional data sets that will be interesting to the people who are concerned about the Green Deal, about climate change, about zero pollution, about climate adaptation, about biodiversity, about the many areas that the Green Deal Action Plan covers. So onboarding to SAGE would support accessibility for many data ecosystems. In other words, one connector should allow you to connect to multiple data spaces and multiple corresponding governance frameworks. So we don't want to have a situation where we have to have a bunch of different technology for different purposes. And even non-connected data sources, like from public data sources like Copernicus, eModNet, et cetera, research infrastructure should also be supported in SAGE as additional data. And longer term, expanding the users and expanding the number of use cases. We have funding for the 10, but we hope to support with a flexible architecture, something that's going to work for many other use cases that are relevant to the Green Deal. And that's all for me, and it's over to Anne. Oh no, Joel, I should say.
Yeah.
I think indeed it's over to Joel. Thank you, Mark. Joel, the floor is yours.
Yeah. Hi. Hello, everyone. I'm Joel Sepúlveda, working on SAGE project as Innovation Project Manager at Innovalia Association. And I would like just to explain you continuously to Mark introduction a little bit of what kind of things we are trying to. The project is recently started, so we are now working in trying to put it all together, the ideas for the use cases. The main thing that I would like to share with all of you related to this Green Deal Data Space approach is that we have a huge kind of different type of use cases, from going from for example, the first use case that we have that is related to forestry and forest management, to some more specific things like, for example, creating a database of pollination of pollinators, and also the natural base economic impact of natural hazards management, and so on and so on. So SAGE is a big opportunity, but also we have a big challenge in order to create, as Mark have mentioned, how data could be shared, and before sharing the data, which are the data value chains inside all the use cases. So when we have defined this, which is the business model in order to, in the future scenarios, which could be the impact of this data sharing across the data space of the Green Deal data space. So we have like 10 use cases, from the forestry to pollinator to soil circularity, data space, also construction environment, the digital twins for building environment, circular textiles that then Anne will explain a little bit more, net zero manufacturing that I will introduce a little bit more now, and environmental hazard data space, natural ecosystem services, and air quality and health data space. So as I mentioned, the degree of development of each of those is so different. So we are now starting to land which will be the potential of the data that will be shared there. Okay. Just as the main timeline, we are now here developing the use case methodology and initial requirements analysis of all the use cases, and which will be the technical necessities and the technical business scenarios. Okay, and we are now in this stage. Related more specifically, it's supposed that today we will speak about the use case of net zero manufacturing. I mean, I understand that all of the audience is somehow familiarized with the methodology and the terms, but just a little bit two slides, so two big issues. The main objective of the concept of net zero in manufacturing industry is that we have try to measure data related to the production and the impact of the CO2 emissions, but not only CO2, because this is, since the climate change issue started about 2000s, all has been always focused in CO2. But in Sites, we also have a little bit of innovation thanks to one of our partners in this use case, that is Satlantis, with his or their quite innovative JSET project related to Copernicus monitoring, because they will, with microsatellites, be a monitorization of CO2 emissions in oil and gas industry. So, I mean, we have like two subcomponents. One is related to the CMM machines in manufacturing direct industry, where scope 3 emissions more related to energy upstreams and downstreams consumption will be monitored, and related to artificial intelligence applications, we will be able even to make a prediction of the production and also prediction of the impact after production. So we can increase the efficiency of the machines in the production line, So it will be like quite innovative in terms of reducing CO2 direct emissions. But also, at the same time, we will try to make a monitorization in real time of the methane emissions thanks to this microsatellite data. So in a potential future scenario, we can develop businesses such as not only related to CO2 mitigations, carbon footprint markets, but also to more not such a big developed methane emissions markets, So I think that the potential of this use case is huge, and now we are working in order to make this happen. And I think that it's quite, we have a lot of motivations there in order to achieve these net zero ambitious objectives, And from my side, I think that mainly this is the summary that we would like to share with all of you. If you have some debate or questions, then after we can discuss all about it. I think, Anne, the floor is yours.
Thank you. I was looking for the unmute button. Really good to be here. I was shuffling my slides around a bit because of Gianfranco. I liked your story about firefighters and like the very practical side of things. And you speaking of CO2 calculations. It's like abstract. It's somewhere in the air. Circular textiles for me is a very practical, physical topic, but just before I go into telling how the data space helps textile to circulate, I kind of want to now give you a bit of intro about how did I land in this topic and who am I. So first of all, Reverse Resources is a company that I have been building for 10 years. And we wanted to solve that textile waste as a resource problem for the fashion industry, and we have been building it for together with the large global fashion brands to help them track how much waste they have from garment production, starting with countries like Bangladesh and India, connecting that with recycling and building a marketplace for the industry. And we have been solving a lot of problems on the way. But one of the issues is that to solve such a problem, we have had to take the approach of connecting data across so many different parties in that supply chain, because circulation of textiles involves a whole circular network of parties. And at some point, we came to an understanding that like to solve this as a business case, we started adding one party, another party. Initially, we wanted to do it between garment factories and recyclers. Then we understood that we need to work with waste handlers. Then we understood that we can't do without fashion brands putting pressure on their factories to segregate waste by composition. Then we understood we have to talk to the public sector. So all these parties come, like we ended up being in a central point of coordination with our data platform. But now learning this, what we have been learning in the Asian markets, we understand that we have the blueprint how to solve this post-consumer waste problem also in Europe, but it would be yet another pool of parties to work with. And as a startup or a business, we can't manage the whole ecosystem together. So that's where we ended up initially setting up TextRoad as an NGO to start looking at how can public sector in Europe approach start asking data from platforms like us to make better decisions on the policy side and build that collaboration with the industry based on the data that we already are creating. And that's where we were then eventually pulled into the textile cluster under the SAGE project to demonstrate how we can actually do this ecosystem approach and actually demonstrate what we can do with the textile industry. This is a vision statement for the textile cluster, but if I word it with my own words, then we all know how fast fashion is blamed to be one of the globalization started there, the industry globalization in the 80s, and fast fashion is blamed as one of the biggest polluters because you can't really govern that global system with one country or region. So now I see this, how textile industry can be, again become a leader to show how through data connectivity we are able to actually measure decoupling. So measure how much money can be made from the same fiber or fabric or product while reducing the use of textile materials. And like physically, we are looking at tons of textile fiber or fabric or materials, not yet calculating it into CO2 savings, because if we look at tons, it's more practical. And the textile industry problem is that we cannot, today we don't have data about compositions of textile. All the statistics is done in monetary value, like how much textile was part of GDP, but we cannot measure how much cotton was used, how much polyester was used. Textile is like an abstract number name in the statistics. So that's kind of the problem statement. And when we look at how Europe has been talking about extended producer responsibility country by country or DPP, looking at product by product, then the whole data structures, everything is scattered. So what we are doing in the SAGE project now is showing how we can design across Europe an information system for the PROs. How can we start collecting data for EPR reporting, create data exchange across borders, across industry and public sector to work together, connecting digital data, product passport data flows, and create statistics so that we are actually able to measure how much circulation is happening, because today we simply have no data and statistics. Like there are bold statements that only 1% of textile reach is coming from textile recycling. Actually, we don't know. So you cannot achieve goals if you don't know baseline, if you don't have targets. So kind of like focus points of the project for us is to show the minimum viable product as an approach of like, how can we actually do it? Because over the 10 years, I have heard like a million times that what I'm trying to do is way too complicated and too expensive. And with reverse resources starting this journey from Bangladesh, it seemed impossible, but today we have a functional market, and the recycling volumes in Bangladesh are growing. So and often when I talk about Bangladesh, the question is like, why are you talking about industrial waste there? We should be talking about European post-consumer waste. But for me, it's all the same material flows. And we have to kind of look at it as a global economics, because there is a lot of this is the reality. We can't kind of go against it. So yeah, showing that we can do it, showing that there is a proof of business case, and that we are able to create public statistics is kind of the goals of this project now. Parties involved are at the moment rather the digital platforms that are holding data for fashion industry. To connect that together, we haven't included so much of the brands because they are already part of the platforms. They already work with us. So all the actual practical use cases are kind of behind the digital layer here. Just to kind of walk or visualize what we mean, we look at the physical material flows of textile, both the reuse or like the linear supply chain, and the reuse and recycling, and like all the different life cycles of textile on a physical level. Today, all the digital services are focusing on one line in that bigger circulation, or one part of it. So the question is how to bring these together to speak to each other, to create connection between the different digital services and digital approaches, and create value from the connection, creating additional elements that support these different services and decision making. So it's keywords: efficiency, transformation, and economic viability. Maybe a few examples what are the more practical impacts of it is that, for example, if we can from one cycle look at how much recycled cotton has been going into production, and we can verify that it came through a compliant waste management system with full transparency, and we can verify that it was actually waste that got recycled, then today we are to pass this data over to a digital product passport to track it down back to the product level. We would need to build all those one-on-one connections. Instead of now with Green Deal Laser Space, we can just simply pass this over so that the data is carried throughout the whole cycles. Or that, on the other side, we're actually able to measure the total recycling or circularity volumes of both reuse and recycling. Today, these are all scattered elements of information. This is kind of an overview of the textile cluster. Any practical example, case study, how to actually demonstrate it. We are very welcoming to include everybody who wants to participate today. And here you can find the email address from my colleague, who is the project coordinator from our side. My name is not Carla, I'm Anne. I forgot what I wanted to add here, so let's go to questions.
Thank you, Anne. Thank you to all the speakers. Thank you to Joel, again to Carmen, Mark. First of all, I see a few questions in the chat. An invite to Anne and all the other speakers. If you have any relevant contact that you want, you would like the attendees to have, you can post them in the chat so they will know where to reach out to, for the project. Now, I will start with the first question that I see here in the chat. I think this is for Carmen from Gerno regarding SmartNAS. And the question goes, is it true that SmartNAS plans data spaces connector on machine level, not on participant level, like it was shown in the presentation?
Okay. Well, first, I was wondering, what do you mean? Who do you refer with participants? I guess machine builders and also, well, I guess also machine owner, because I mean the machine, the asset, as can be transferred between different with different entities. So we want certainly participants in the so legal entities as a stakeholder in the data space, but yes, also we envision the connection of the machine, since it is the main data provider, data generator, and it is around the machines, the equipment, that our vision of the Federation of Data Space is built. This will be possible. Well, also it depends on the technically, I think yes. But also here is, I think that is seldom said in the data space. The technological aspect is only one piece. There are aspects of the governance and especially of the companies to get engaged in this adventure, so to say.
If I can jump in, I like the question also because it looks a lot at the future, and knowing Gernot, who is also a colleague in DSSC, is probably also thinking of intelligent machines, autonomous machine, agentic agents, and there are many situations already today where in manufacturing we use machines that perhaps we do not own, but they are working on lease from other manufacturers and so on. In microprocessor design and production, this is super common. So where is the responsibility, where there is the legal entity? Now, this is a conversation probably for the geeks, and I don't want to bore the audience too much, but it is one of the elements that some of us in the team are getting crazy with, because when you start having those autonomous entities, when the ownership of the machine is not clear, and this machine does something, who is the participant, right? For some of us, I know this is being discussed literally in the DSSC, when individuals offer data, are they the legal entity, or there's always an intermediary in the middle? So these are, I don't think they are completely resolved matters, and to some degree, the doctrine, let's say, that comes out of the DSSC depends also on the most common views at the moment, what is easier to communicate and implement. But I have a feeling that for some time we will not have a single answer to that question. I see Mark nodding. Can I pull you in, Mark? What do you think about this?
Well, it is complex. There was a lot of discussion last week at the Gaia X event about exactly this point. There's some back and forth. If you're entering into a data sharing contract, into a even if you're doing it with technology, you do need to identify somebody that is legally responsible for that. That can be a person, but it can also be a company. So in the case of the machine that's rented from some provider, probably the difficulty will be that the leasing contract says, well, you can't have the data. So there needs to be a modification to that leasing agreement to say, oh, well, yes, you get to have the data as well as the machine. So it's a small nit, but it's something that can be worked out. I do think it's reasonable that individuals should be part of data spaces, should be able to contribute data to data spaces, get data from a data space, participate, as I was saying in my slides, in a data ecosystem. There are going to be individuals in there, and we cannot limit it to companies with VAT numbers, etc. So it's something that needs to be sorted out, and it is a little bit of an argument right now, which we really don't need at this stage. So anyway, that's the geeky point of view, and if you're not following it, don't worry about it.
Yeah, I can imagine people
Ignore
going
that
blank.
man behind
What
the
are these
curtain.
people talking about?
Yeah, exactly.
But I believe it feels like that just because it's new, right? In the UK, for example, there's a lot of talking about let's say data. How do they call them? Practically entities that represents individuals in the proxies or
Avatars.
yeah, exactly, trusts, data trusts, right? That is another kind of level of abstractions where in the same way you would trust a financial advisor to manage your finances for you with some degree of regulated responsibility.
But if you're a data trust or a data pooling organization or any of these flavors that people have talked about in different documents, those are legal entities. So they act on behalf of the individual, and in part they act on behalf of the individual because the individual cannot be bothered to answer all the requests to consent to the use of their data because they're like, oh my God, my phone is blowing up. I'd much rather have it blow up with all my friend requests in Facebook than to have it blow up with a bunch of data access requests, which are really boring. So it's about making that happen. But let's bury that one and talk about fun stuff like textile recycling and machines that will be better, manufacturing that will be better.
And from the point of view, also looking at the chat, where the other tabs warm up and think what to ask, I have one that probably accumulates all of you. That is, who pay for what you describe, right? So when we're talking about sustainability and the Green Deal, who is paying? What are the business models by which everything you've been spending so much effort can justify what you're doing? Have you been exploring the typical patterns? Probably anybody in your place would be following, or perhaps there's no good single answer yet. I don't know who we want to take it first. Let's start from textiles. Let's start from Anne.
Wait, I didn't follow your question. Can you repeat?
Yes, I was asking if there are patterns in the business models for what you described. So when introducing an element of sustainability and green, it's not as obvious as providing a commercial service, right? Who is paying for the extra elements by which we document provenance and we ensure the materials are the ones we described and everything? Who is paying for this complex machine we described?
Well, in this case, what I see happening is that every digital platform that we are connecting has somehow figured out how to offer a service to the industry that adds value. And there is this sweet spot of like, if I could have access to yet some more data that I don't need to invest into getting that access myself, but the data comes naturally, then it starts fueling my business. So that means that I'm also interested, I'm also ready to pay for or kind of channel that the business results into that pool.
It sounds like kind of a virtuous circle where even just the basic advantages of becoming part of the new system pays for itself in a way, for the extra effort, for the onboarding in the new system and everything, which sounds already reasonable like this, right?
At the same time, there is also, if you take textile waste as a cost for Europe, with the directive of collecting textile waste separately, there is a certain cost related to the collection and incineration or landfilling of it if you can't recycle it. If you don't recycle or collect it, you pay fines. So that cost itself is like a headache now for countries, and there seems to be no solution. So it's like creating that ecosystem approach. We actually are solving this problem, but and creating statistics is yet another problem. If like we have, like, for example, Dutch Statistics Bureau, part of the project, if they would want to measure textile circulation themselves, how much new reporting they would need to set up, how much time and effort it would go to actually get the data. That's where we are kind of pooling that information together to feed, like avoid that cost. So there is the cost element and the saving element on both public and private sector side.
From that point of view, we should expect some support from local governments that usually is responsible for those functions that you described. So the combination of the individual advantage for the companies participating in the process and the expected savings and optimization of the processes for the local authorities should comfortably, you may say, it's a reasonable assumption that could pay for the cost of operating and designing a system like this one. May I ask what Sage thinks about this? What are the business models you see on for the rest of the universe?
My view on this topic, Gianfranco, is that that traditionally has happened in the world of climate change and before climate change sustainability. It always happened that normally you have to push companies by regulatory terms and policy issues, but challenging decisions in that terms, not only from the managerial point of view, but also from the environmental policy designers, is that once you achieve the objectives, the motivation, if there is not business related, it's already okay. I have achieved my challenge, so the motivation, I have to push out my motivation, so okay, it's enough. And this has happened in the last 25 years if you are related in the sustainability world. So I think that one of the main advantages of this new deployment of data spaces is that we can really see what is the next step and the scenario of, for example, Carmen also have mentioned in the Smart, and as the 80% of the data of the industry is not working out for making new businesses, and also happens in, for example, in our use case of the net zero manufacturing, on the scope 3 mitigation objectives, more or less normally the 75% of the data is lost and is the more difficult in order to manage to reduce your CO2 or methane mitigation impact, So the data space itself, this technology and the deployment of this Green Deal data space will help us not only to achieve this, but also to see the business scenario for the future. So I think that the main competitive advantage is that we have the opportunity to jump not only to achieve the regulatory terms, but also to see more further positive impacts,
Jerry, you sound a bit like, in a way, it's like we need to throw our heart beyond the fence, right? We should not think about short-term micro business models to justify getting one step forward, but rather project ourselves to what this would feel like if data spaces were infrastructure. I mean, Mark should help me before talking about this, saying infrastructure is not visible, right? Infrastructure, when it succeeds, you just take it for granted. As incredible as an incredible achievement as it is, you don't calculate it in your business models. You can build a restaurant thanks to the fact that you have water and you have sanitation and everything, but you don't really build a business case saying, I have water and sanitation, then I can build a restaurant, right? So if we are 20 years in the future and data spaces, technology, and practices are consolidated, it should feel so normal that we should just worry about what to innovate on top of them, because they are already there. They're already infrastructure coming to our offices and our houses and our plants. I'm curious to hear from Carmen. You disappeared for a second. I wanted to hear from you. How does all of this conversation look like business-wise? Is it easy to persuade your participants to jump on the system and to innovate in the direction of data space for manufacturing, or there's still some oiling of the machine to do, pun intended?
Well, as you know, we have, the question that has been posed regarding the sustainability for the smart tenants data space is crucial for the manufacturing data space, because this is a bigger entity, no? And for the long-term sustainability, it requires the support of manufacturing companies. We cannot rely forever on public funding, even if at the beginning we can expect some. As also my colleagues have said, when there is a clear business value and advantage for the companies, there is also a certain openness, to sustain this model. But we are at the moment looking into traditional business models and also trying to figure out something new to maintain smart tenants on the long term. But yes, there is still some oil for the machines to involve all the partners. And I think this will be the main challenge in the second half of the project.
Okay, we'll be watching you.
Thank you.
Anna, back to you if you see something in chat or...
I don't see anything in chat, but unfortunately we are also almost running out of time. So I will start with a bit of a closing remarks. So thank you to all the speakers. Thank you, Gianfranco, for the opening, Joel, Carmen, and Mark. Thank you very much. This webinar is recorded, so we will share the recording of this webinar on our YouTube channel, and you can access it if you want. Thanks to the attendees, which are still hanging around despite it being pretty late in the afternoon. Thanks for the questions, and we see to all the DSSC community, we still have one DSSC Insight Series ahead of the summer, which is next month. So stick around and we'll hear on our channel soon the topic and then a guest speaker. But thanks again to everyone, and I wish everyone a wonderful evening.
Bye.
Thank you.
Thank you.
Thank you all.
Bye-bye.
Bye-bye.
Bye.